All right, so today we're going to take a closer look at the definition of a limit. So if we have some function f of x, and I'm just going to draw a little picture here. We'll draw some f of x. All right, so let's say f of x just looks like this. So this is f of x. So we have an x-axis and a y-axis. And we're interested in what happens to the value of the function as we approach some x value, and let's call that a. Okay, so we're looking at what happens as x approaches a. All right, so now it may have some value, but we don't actually care about what's happening at a. We're only interested in what happens to f of x as we approach a. All right, the function doesn't even have to be defined. Whoops, at a. And we're just looking at what happens as x approaches a. What happens to the value of the function as x approaches a? And if that the value of the function approaches some number L, right? Some limit L, then we say that the limit as x approaches a of f of x is L. Okay, so let's look at example one. Hopefully that'll make more sense. All right, so example one, we have a function f of x. Okay, f of x is equal to x squared. So you have a pretty good idea of what f of x looks like if I were to graph it, right? It's just a parabola with a vertex at 0. So the first task here is just to complete this table. All right, so I went ahead and completed this table offline, so you don't have to watch me write all these numbers, but you can see that what we're doing is we're taking values that are getting closer and closer to 2, all right? Either from the left, right? So these are values that are less than 2, 1.9, 1.99, 1.999. We're getting closer and closer to 2. Or we're approaching from the right-hand side, right? 2.1, 2.01, 2.001. Those are just values that are getting closer and closer to 2. And we want to look at what's happening to the value of f of x. All right, now you can see that this value is getting closer and closer to 4. So we can write that the limit as x approaches 2 of either we could say f of x or we could just write x squared, right, is equal to 4, which is kind of what we would expect, right? Because we can actually go there. We can actually put in x equals 2 and square it, and we'll get 4. And it makes sense that as we get closer and closer to 2, those values are going to be approaching 4. Okay, so, but sometimes we can't just go there, right? We have to sneak up on it. There's no other way to do it but to use a limit. So this next example is an example of that, right? If I tried to put in, let's see, we're looking at the limit as x approaches 0, right? So we've got this table just like we did before where we're approaching 0 either from the left or the right. Now, if we actually try to go to 0 and plug in 0, we get, what do we get? We get e to the 3 times 0, which is 0, minus 1, all over 0. So we get e to the 0 is 1, so 1 minus 1 is 0. We get 0 over 0, which doesn't make any sense. That's undefined. So we don't really know, based on just plugging in the number, we don't know what's happening as we approach 0, okay? So let's first of all just take these numbers that are given and plug it in to f of x. All right, so I've gone ahead and done those calculations out offline. Right, I've just put in these values of x into our f of x and calculated these values. So now, based on what I'm seeing, right, these numbers seem to be getting closer and closer to 3. So I would estimate that the limit as x approaches 0 of this function e to the 3x minus 1 over x is equal to 3. That is what it looks like is happening, right? Even though we can't plug in 0, right, into the f of x, we can see as we get closer and closer to 0, the values of f of x seem to be approaching 3. And that is the beauty of limits, is that we can sneak up on a value even when we can't go directly to that value.